Hello, weather enthusiasts. Welcome to Tornado Extreme, your one-stop channel for all things tornado. We're here to whirl you into the world of weather phenomena, offering a deeper understanding from a scientific perspective. With us, you'll explore the formation, measurement, and characteristics of tornadoes, focusing specifically on the intriguing multi-vortex tornadoes. We'll also discuss where these fantastic forces of nature are most likely to form and recall some of their most deadly appearances. Today, we're diving into the fascinating world of multi-vortex tornadoes. Multi-vortex tornadoes are a unique and intriguing phenomenon, but what exactly are they? To understand multi-vortex tornadoes, we first need to grasp the basics of tornado formation. It all starts with a thunderstorm. When warm, moist air at low levels collides with cool, dry air aloft, it creates an unstable atmosphere. This unstable configuration can give birth to a thunderstorm. As the storm intensifies, the change in wind speed and direction with height, also known as wind shear, can set the air spinning in a horizontal direction. Then the updraft from the storm can tilt this spinning air into a vertical position, forming a tornado. Now let's delve into the specifics of multi-vortex formation. These tornadoes are not your typical twisters. They contain two or more smaller, intense subvortices circling the center of the larger tornado circulation. These subvortices can cause extreme winds and damage in a very localized area. The formation of a multi-vortex tornado is still an active area of research, but it is believed to be related to the distribution of wind and temperature near the surface of the storm. If the conditions are just right, the tornado's rotation can become unstable and break up into multiple smaller vortices. These subvortices, also known as suction vortices, whirl around the parent tornado and can cause the most extreme damage. Each of these vortices acts like a mini tornado with its own funnel and debris cloud. Multi-vortex tornadoes can be particularly destructive. The combined forces of the parent tornado and its subvortices can result in a path of devastation wider than the tornado itself. This is why multi-vortex tornadoes are often responsible for the most catastrophic tornado damage. The science behind this phenomenon is complex and fascinating, involving a delicate balance of atmospheric conditions and physics. It's a testament to the incredible power of nature and the intricate processes that govern our weather. That's the science behind multi-vortex tornadoes. Fascinating, isn't it? Now that we understand what multi-vortex tornadoes are, let's explore how scientists measure these powerful storms. Believe it or not, the scale we use to measure tornadoes is based on damage, not wind speed. This is because it's extremely difficult to measure wind speed directly inside a tornado. The scale we use today is called the Enhanced Fujita Scale, or EF scale for short, and it's an upgrade of the original Fujita scale developed by Dr. Tetsuya Fujita in the 70s. The EF scale rates tornadoes from EF0, which are relatively weak, to EF5, the most destructive. An EF0 tornado might damage roofs and break branches, while an EF5 tornado can lift houses off their foundations and hurl cars like toys. But don't be fooled, even an EF0 tornado can be dangerous. The EF scale takes into account more than just the damage to buildings. It also considers the damage to vegetation and the type of buildings affected. For example, a tornado that destroys a brick house is likely more powerful than one that destroys a wooden house. But the EF scale isn't perfect, it's subjective, and it depends on people accurately assessing the damage. That's why scientists are always looking for more precise ways to measure tornadoes. One such method is using Doppler radar, which can estimate wind speeds within a storm. Another is deploying tornado probes, which are devices designed to be caught in a tornado and measure wind speed directly. There are also mobile radar units that can get close to tornadoes and measure their wind speeds. These units can provide valuable data, but they're risky to use because they have to be so close to the tornado. In recent years, scientists have also started using drones to study tornadoes. Drones can safely get closer to tornadoes than any human or ground-based instrument, and they can capture high-resolution images that help scientists analyze the tornado's structure. That's how multi-vortex tornadoes are measured, giving us a better understanding of their power. Multi-vortex tornadoes have some unique characteristics that set them apart. Unlike their single-vortex counterparts, these tornadoes are not just one funnel of spinning air. Instead, they're composed of several smaller vortices, or subvortices, swirling around a common center. This creates a terrifying spectacle of multiple tornado funnels dancing around a common point, a sight both awe-inspiring and chilling. In terms of appearance, multi-vortex tornadoes can be a little deceptive. From a distance, they may appear like a single large tornado, but as you get closer or view them from an aerial perspective, you start to see the individual vortices spinning around each other. Each of these vortices can be as powerful as a standalone tornado, and the combined effect can be truly destructive. Speaking of destructive potential, multi-vortex tornadoes are some of the most devastating weather phenomena on the planet. The multiple vortices mean that the damage path can be wider than that of a single vortex tornado. Each subvortex can carve its own swath of destruction, leading to a damage pattern that can seem chaotic and random. The wind speeds within these subvortices can also be extremely high, often exceeding those in the parent circulation. This can lead to some particularly intense damage. The behavior of multi-vortex tornadoes can also be unpredictable. They can form and dissipate rapidly, making them difficult to track and forecast. The subvortices can merge and split, change speed and direction, making the tornado's path and intensity difficult to predict. This unpredictability adds another layer of danger to these already formidable storms. In terms of lifespan, multi-vortex tornadoes can last from a few minutes to over an hour. The duration of these tornadoes, like their formation, is influenced by a variety of factors, including the stability of the atmosphere and the strength of the parent thunderstorm. These characteristics make multi-vortex tornadoes a fascinating subject of study. They challenge our understanding of tornado formation and behavior, and remind us of the sheer power and unpredictability of nature. Understanding these tornadoes better can help us improve our forecasting abilities and hopefully save lives. Where in the world are you most likely to encounter a multi-vortex tornado? Now that's a question that keeps weather enthusiasts on their toes. Multi-vortex tornadoes, as their name suggests, have multiple vortexes spinning around a common center. These twisters are especially likely to form in regions known as Tornado Alley and Dixie Alley in the United States. Why these areas, you ask? Well, it has a lot to do with the unique atmospheric conditions found there. Tornado Alley, stretching across the Great Plains, is particularly prone to multi-vortex tornadoes due to the vast, flat landscape that allows cold, dry air from Canada to collide with warm, moist air from the Gulf of Mexico. This clash of air masses creates the perfect conditions for these multi-vortex tornadoes to form. On the other hand, Dixie Alley, which includes parts of the southeastern United States, sees a high occurrence of these twisters due to the combination of warm, humid air from the Gulf of Mexico and the frequent cold fronts that sweep through the region. This creates volatile conditions ripe for spawning these powerful tornadoes. But let's not forget the central part of the United States, where the Rocky Mountains lee side also sees a fair share of multi-vortex tornadoes. The unique topography here can cause drastic changes in wind direction and speed, leading to the formation of these complex twisters, so those are the hotspots for multi-vortex tornadoes. Some multi-vortex tornadoes have left a lasting mark on history. Let's take a moment to remember some of the most devastating multi-vortex tornadoes that have etched their names into the annals of meteorological history. Their impact and aftermath serve as a stark reminder of the destructive capacity of these natural phenomena. One such event is the infamous Tri-State Tornado of 1925, which rampaged across Missouri, Illinois, and Indiana. This tornado, believed to be a multi-vortex event, still holds the record for the longest tornado track and the highest number of fatalities in U.S. history. Over 600 people lost their lives, and thousands more were injured. Then, there was the super outbreak of April 1974, where a total of 148 tornadoes, many of them multi-vortex, swept across 13 U.S. states and the Canadian province of Ontario in just 18 hours. This outbreak resulted in 315 fatalities and caused extensive damage across the affected regions. In more recent history, the Joplin tornado of May 2011 tore through Missouri, leaving a path of destruction in its wake. As a powerful EF5 multi-vortex tornado, it claimed 158 lives, making it one of the deadliest tornadoes in modern times. These events remind us of the incredible power of nature. Each of these tornadoes has left a trail of devastation, forever changing the lives of those in their paths. Their stories emphasize the importance of understanding and respecting these formidable forces of nature. That's a whirlwind tour of the world of multi-vortex tornadoes. We've journeyed through their science, how they're measured, and their unique characteristics. We've pinpointed where these powerful phenomena are most likely to form and recounted some of the deadliest instances. Each facet underscores just how awe-inspiring and formidable nature can be. Thank you for joining us on Tornado Extreme. Don't forget to subscribe and visit our website, tornadoextreme.com, for more tornado-related content.